welcome to Fresh Thinking by Snowden Optiro, a podcast where we explore the technical aspects of the mining industry. My name's Tarrant Elkington, General Manager for Snowden Optiro here in Perth. And today we're joined by a special guest, Joe Dos Santos from Santos International. And Joe's widely recognised as an expert in bulk material handling systems and the founder of a particular technology called sandwich conveyors. And when I heard about this, it's a particular breed of high angle conveyors. When I heard about this, I was quite interested in it because I know that there's many clients that ask about high angle conveying and the pros and cons. So I thought it'd be great to have Joe explain to us a little bit more about it. So I hope everybody enjoys the conversation. So firstly, welcome to the show, Joe.
Thank you.
So I guess to start with, could you just explain to us a little bit about what sandwich conveyors are?
Be happy to. So if you already know something about conventional conveyors, open trough belt conveyors, it's basically a rubber belt that's troughed by troughing idlers, 3-roll idlers that make the trough, and a drive pulley, tail take-up pulley, and the material is loaded on one end and discharges out the other. That trough conveyor is able to convey material up until the angle where the material will start to slide back, somewhere around 15 degrees, depends on the material. Sandwich belt high angle conveyors basically use 2 of those belts, each with its drive pulley, tail take-up pulley. The material is first loaded onto an open trough belt, which is the bottom belt, then is joined by the cover belt or the top belt, and they form a sandwich. Then along the path, with the material sandwiched in between, hugged, the material's friction is developed, and the material can then be conveyed at a high angle without material slide back, even up to 90 degrees. How to do it is very important. Continuity of hugging, material must be hugged without lapse, even at the smallest scale. Otherwise, gravity will cause that material to move. And the ability to do that, how to do that, is very, very important. But the equipment is all conventional conveyor equipment. 3-roll troughing idlers. There's a 4-roll hugging pressure device, which is fully equalized, that ensures that the material is always hugged. But other than that, it's 2 belt conveyors arranged in a way that allow you to convey bulk material up a high angle up to 90 degrees. I hope that's as clear as I can make it.
Yeah, absolutely. And maybe it's obvious, but maybe you could explain what the applications are for this type of conveyors.
Well, the applications are the same as any conventional conveyor. Anywhere where you convey materials, could be mining products, crushed rock, or it could be grains, wood chips, pulp and paper mills, sulfur prills. Oh gosh, it goes on. Coal, of course. Just the various materials, but these are bulk materials, loose bulk materials that get conveyed on conventional conveyors. Any of those materials can be conveyed on a high angle conveyor, and it basically allows you to take the most direct path from point A to point B, even if that path is not a low angle.
If for example, in a pit, right? That's I suppose a classic example where you have slopes that are steeper than than you could convey out with conventional conveying, right? So rather than have to convey out a conventional ramp sort of geometry, you can go up the side of the wall.
No, indeed. That's the whole impetus for the high angle conveyor development was indeed open pit mining. The U.S. Bureau of Mines sponsored a study at a company in Pittsburgh, Pennsylvania, Trevaux Corporation. I was a young engineer at the time and became a member of that study group. And the purpose of that study was to develop a direct path out of the pit directly up the mine wall, a high-angle conveying system. Now, prior to that, in-pit crushing and conveying systems used conventional conveyors. Now, the only way you can scale a pit at its natural angle of operation, which is typically the natural angle of repose, would be to either take conveyor segments and basically spiral them up the ramps in order to not have excessive additional excavation. You could cut a slot into the pit, the entire, to be able to get out, and that typically required much more excavation than would be needed just for the process of obtaining the ore. And then another method that was used was basically a tunnel through the high wall coming out at a remote location on the surface. All of this was done because of the limitations of a conventional conveyor, conveying up to about 15 degrees. And so the high angle conveyor solved the problem. It allowed you to get directly out of the pit in the most direct path without in any way negatively influencing the amount of excavation required, other than the excavation required to obtain the ore. It basically eliminated any additional excessive excavation.
And what about this is not the only high angle conveying technology that addresses this, right? There are other technologies. Can you just maybe just summarize what they are and how they compare to sandwich conveyors?
Okay, you mean other high angle conveyor technologies?
Yes, correct.
Yep. Sure. Yeah, sure. There are bucket elevators. Bucket elevators are older than conveyors. Bucket elevators existed at the beginning of civilization. They have been around for a long time. They're continuous, but they elevate in discrete buckets. And some of the shortcomings with bucket elevators, they're very mechanical, very wear and tear prone, and they're very limited with regard to material size, and they're very high wear and tear. I guess I said that, and very high maintenance. Okay, so and they're very limited in capacity too. In mining we talk about thousands of tons per hour. 1,000 ton per hour bucket elevator is a very, very big bucket elevator. There are bucket elevators that are built to 10 feet wide buckets, and once you get into that realm, they become very, very expensive. They become non-competitive. Not the case with a conveyor-based, a belt conveyor-based system. So that's an item. There are pocket belts. They're basically flat belts with sidewalls, and the sidewalls are corrugated rubber with cleats across. And those they're actually very successful. They're very, very expensive, and somewhat limited in again in tonnage. They're better than the bucket elevators, but they're limited and they're very, very expensive. What are some of the other items? Well, I mean the skip hoist. That's not a continuous conveying system. That's a batch system. And so a skip hoist is a big old bucket that's takes a large volume of material, bigger than a truck, and then uses one bucket going down while the other one is going up, so that you're only actually powering, lifting the pay material, if you will. And skip hoists have been around forever in underground mines. They call them winders, and but they have they're very, very expensive and huge logistics issues, because the size of the amount of material that you're taking, that means you have to have a complete system underground where you store the material that you're then going to load into the bucket, and then you have to have a way of offloading it up at the top, because it's not continuous. So that you're basically putting them into a hopper, then a feeder, then to the skip, then up, then you're putting it into another hopper, into a feeder, then onto a conveyor. So yeah, it's very big logistics problems. A conveyor-based system like a sandwich belt high angle conveyor, which operates just like any conventional conveyor, is a continuous system. There's not a need for any of that transitioning. And sandwich conveyors have the characteristics of conventional conveyors. They're very economical, they're very low operating maintenance, and they have very high availability. The other systems don't. I should say that the bucket elevator is very damage prone. The pocket belt is an improvement, quite an improvement, but it's very, very expensive, especially at the tonnages that we talk about in mining, and when we talk about thousands of tons an hour.
Yeah, and I guess on that point on production rate, so I think that's something that that people might not, I guess, appreciate. You know, they probably think that there's a trade-off with the steeper that you go, the less the production, right? And I'm not sure it's quite that case, right? That's probably a bit of a myth. I'm not sure if it's a myth I created, but can you can you maybe explain a little bit about the product, you know, the production rates capable of these sandwich systems?
Yeah, actually, no, it's a valid point. A conventional conveyor basically heaps material in the trough, which is the belt, and then with a surcharge angle, you're basically getting a lot of material for a given belt width. Now, a sandwich belt high angle conveyor is capable of very, very high tonnages, but it's not as high tonnage as the conventional conveyor. But because we can get whatever belt width we need to do the function, in principle, there's no limit as to the tonnage on a sandwich conveyor. It just means that sandwich conveyor, its belt width is going to be wider than the conventional conveyor feeding it. But in principle, there is no limit. And yeah, to give you an example, I did this recently for a mining class at the University of Arizona, where I made a comparison, just basically ran calculations for a 120-inch wide belt. 120-inch wide is 3.048 meters. Okay, that's the width of the belt. And with a conventional conveyor, of course, limited by its angle, with a conventional conveyor at its normal surcharge, we were able to accomplish some 33,000 tons an hour on a single conveyor. That's a lot of material moved. On the sandwich conveyor, that number was more like 24,000 tons an hour. So you see, for the same belt with same belt speed and so on. However, that is still a lot of material, way beyond any of the other systems that we talked about, way beyond what a bucket elevator or a pocket belt could accomplish. Yeah. So okay. In principle, there's no limit, but it is a less tonnage than the conventional conveyor, because the conventional conveyor basically heaps the material on a belt that's troughed, whereas the sandwich conveyor puts it between two belts and allows a certain amount of edge distance so that your material stays contained.
That makes sense. And so, what, like, if I was, you know, what are some of the resistance, or maybe the technical challenges that we have with these sandwich conveyors? What are some of some of those things that you've come up against over the last 30 or so years looking into this technology?
Yeah, well, we've had a lot of success, great success. We've not had great marketing success, because otherwise people wouldn't be wondering about it. They'd be using them all over. We have them all over the world, on all 6 civilized continents. We don't have any in Antarctica, but nobody's conveying anything down there. So yeah, they're very successful, but they're not widely known, and there is a lot of resistance to what's perceived as new. Now, having said that, they're not new either. The study that I mentioned was between 1979 and 1981. commercialization happened in 1982, and so they're not new, but they're not well known. And then in the in-pit crushing and conveying applications, as you know, and you said it at the beginning, that the IPCC systems tend to be very expensive compared to the trucking systems in terms of total capital. So they're a tough sale, although there are many in operation and many in very successful operation. They're a tough sale. Attach that to a sandwich belt high angle conveyor, and the sale is even tougher with very conservative mining people. So that's some of the challenges. As far as operation, in terms of the materials, if the material is conveyable, it's conveyable. It's just like any conventional conveyor. There are some materials that are not so conveyable. There are some materials that basically aerate when you basically, in fact, they aerate cement. It aerates and behaves like a fluid, even on a conventional conveyor at a conventional angle. So that's well known. So there's some materials that are a little bit more difficult. I know that a lot of our customers, without any agreement from us, will take the dust that comes off of their dust collectors, all of it, and they'll put it at the tail of our high angle conveyor. And in a lot of cases, they get away with it. It's minor dust, but when that dust becomes 20–30% of the total flow, it basically behaves like a fluid and just comes out. So yeah, those are some of the challenges. Some materials are more challenging. They tend to spread a little bit more. They tend to aerate. So yeah, those are some of the challenges. But overall, it's behaved like any conventional conveyor. It's handled materials that have internal friction, internal angle repos.
Are there challenges of construction, like just logistics of construction and maintenance? You know, when you're running up a steep wall which has less access maybe than a normal conveyor would typically have.
That indeed is a case, and is a case with any elevated conveyor. Any elevated conveyor is basically on bends, trusses, and then has access on both sides in order to get to it. And so that's always going to be the case on a high angle conveyor, almost always. Whereas on conventional conveyors, that may be the case. And, if you're going up to a silo on trusses with bends, but on the other hand, there are many conventional conveyors that are on sleepers along the ground, no access needed. You're walking along the ground. So, in principle, that's much easier to take care of. So you do have the challenges of the elevated structure, but again, it's just like any elevated conveyor system.
And so what is it? Has there been things that are put in place to help, I guess, manage the maintenance and whatnot of the systems?
Small things. The small things have been done here and there. Some maybe a little bit bigger. Monorails, like a monorail with a with a drop hook to take a bucket of tools to take to hook an idler to, and being able to take it down to the position, and then not having to carry it. That's something that's done often. We had a system in Spain where they decided to eliminate, on one side they decided to eliminate the stairway, and this unit was 70 degrees, so it was a very high angle, and so basically access was by cage ladder and landing, just one cage ladder to landing and so on. And they took one of them down and put in a hoisted platform and used that for a while. So yeah, those are some of the things that you can do to facilitate access.
What's the highest, high angle conveyor, the longest, very steep conveyor that you've put in? Is that?
I mentioned the Maidenpick high angle conveyor system, which was part of an IPCC system in Yugoslavia, Serbia. And that unit was 90 meters of 90 meters of net lift, was six 15-meter benches. It was 93 meters of total lift. And the length of it, I believe, was 165 meters. That's an example. And that was a significant system. That was a 2,000 ton an hour system, 10-inch minus material being handled. That was not by any means the largest system. The longest system prior, we have one in process right now that I'll mention, but the longest system prior to that was going up a Virginia mountainside, handling mine refuse from a coal prep plant going to a permitted valley. And that was 175 meters of lift. I don't remember the length. It was going up the mountainside. It was averaging, it was going up 37 degrees, then went horizontal for a little while, then up at 41 degrees, and ultimately to the discharge point. But it was 175 meters of lift. Today we have a system under construction right now, which should be operating in the next several months. It's a vertical system coming out from an underground mine, and that system has a lift of 240 meters. It's some 1,400 tons an hour. It's a 1.4 meter wide belt. It's actually a 54-inch wide belt. So
you're effectively trying, like in an underground context. That's interesting. You know,
yeah, this is a vertical system.
Like a hoisting system, right?
Indeed, this is a vertical system coming up a a cylindrical shaft.
Yeah. Okay. Oh, that's interesting. Are there any I was wondering in terms of the take up of the system, is there any like pockets of the industry, you know, sweet spots that you've found in your time that have, like, you know, been more interested or more willing to take this technology on?
So ironically, the industries that stand to most benefit from the system are actually not the best customers. We have been selling high angle conveyors in areas where we never thought we would, never thought about it, never considered it. As I said, the system, its development, the impetus for it came out of open pit mining. And we have had great success in pulp and paper, handling wood chips. One of the things that we always sort of advertise and claim is that our system is very gentle. It hugs the material, and that works in two directions. In one case, it does not hurt the material. In the other case, action and reaction, it doesn't hurt the equipment. It's very gentle on the equipment. So when you're handling very heavy, sharp rock, you're not punching into the belt. The system is equalized, it yields, and it's very good that way. So it's good on the equipment. In the other direction, when you're handling something like grain, wood chips, you're not crushing the material. And early on, when we developed the system, that was important for us to demonstrate that, and we demonstrated in grain. And it took us forever before we ever got our grain order. We got wood chip orders before that. And in the case of wood chips, if you're familiar with the industry, basically you're bringing in wood chips that are cut to a certain size, then they are screened for quality. And that quality, the size and so on, is very important to the pulp yield. And if you screen the chips and then you subject them to damage, create fines, pins and the like, you get all kinds of problems, including loss of yield. And so we had a customer that read our flyers on how gentle it was on the material aimed at grain, and they latched onto it. They were screening their chips, and they were then, after screening their chips, they were conveying it to the digester with a blow line. All they were doing is just destroying them again after screening them. And so the blow line was a 500 horsepower blow line, taking the materials up to the digester and they had a lot of loss. They had they estimated 5 to 10% loss of yield. And so that's what brought them to us. They did their own test. The test that we had done on grain, they repeated on the wood chips to demonstrate that there was no damage. And then they bought our system, a 48-inch wide conveyor, 60 horsepower, replaced their blow line. Remember what I said, the blow line was 500 horsepower. So, and they realized just phenomenal savings. They estimated, this was a long time ago, so the total price or total cost of doing that was some $340,000, $340,000. Just from the start, they saved $93,000 a year just in power costs, because as I said, it was a 60 horsepower high angle conveyor replacing a 500 horsepower blow line. And of course, that 60 horsepower wasn't using all that 60 horsepower. And then they estimated that within 6 months to a year, that system paid for itself, not in the power savings, but in the savings in the wood chips and the pulp yield. So yeah, that's a perfect example of an area where we never thought about that when we were developing the high angle conveyor. We were thinking about mining applications. Since then, we've also done grain handling applications where, finally, because that was a target for us with regard to, why we did all of that damage testing. And that's also been realized. We had a self-unloading, a loading barge, a transshipment barge, where you're taking material from river barges to ocean-going ships through a clamshell, then through various stages of conveying. And our high angle conveyor in that case saved the day, where they were originally looking at a multiple of bucket elevators to do it. It would have taken them 3, 4, 5 bucket elevators to handle what we were handling, 2,000 tons an hour of grain. And we handled that on an 84-inch wide belt, 84-inch, 21, 34 millimeters, 2.1 meter belt. So yeah, those are areas. Then sulfur, so as I said, the unlikely customers are customers that are buying these systems at very, very low tonnage. And sludge handling and municipal sludge, little systems. We had a system in a handling magnetite at a chemical plant right at the border of Germany and France. A little thing, little 24-inch wides. We never expected that, and we're still surprised when we get them. But we get a lot of those, and those are not where the big payoff is. The big payoff is in mining. And those, we've gotten a lot of mining applications, but nowhere near the success that we envisioned.
Yeah. Okay. And what about in mining itself? I mean, is there's some applications that you've that you found there or been able to put into practice?
Yeah, we've had a lot of success. We've had a lot of installations in mining, just not where we targeted, not in the IPCC system. To this date, the only true IPCC system is the system that I mentioned that was in Yugoslavia. We've had them in the mine perimeter. We've had them at the mine plants. We've had them in the yards. We've had them going up to feed ship loaders. We've had them. We've had success in mining, but the applications in IPCC have been a little bit disappointing, and they're always about to come. And we over the last couple of years, we've had just phenomenal interest, in fact, from Australia and also from South America. And we've done some paid studies, which I believe will be realized as installations soon. But they've been slow coming. And I say this because, as I said, the system that we developed for that purpose was we did it between 1979 and 1981. So yeah, it's just.
And just in terms of that trade-off, like in the pit, when we firstly, as you said before, we're only talking about replacing a portion of the system, not the entire conveying system. It will fit into a traditional conveyor system. But if we just look at the length of that lift that we're trying to get the conveyor out, I guess thinking through that, obviously the length of the conveyor and hence the equipment is less, right, than a conventional conveyor to get the same amount of lift, right? So the amount of I guess direct steel related with the conveyors. Of course, there's some steel associated with the elevation, right? And your belt widths for the same throughput are slightly wider, right? But if you are doubling or tripling the angle that you're conveying at, there's quite a reduction in length. And what about power? Is there what would be the difference in power requirement for the high angle conveyor versus the traditional conveyor?
Well,
For the same, let's say for the same lift, right?
Yeah, both are very, very efficient. The high angle conveyor, well, it depends on how heavy the material, but for a mine material, crushed rock or whatever, the amount of energy consumption is basically 85% of it is useful work and 15% of it is losses. So when I say useful work, it's basically the useful work that it takes to lift material from one elevation to the next. You can't get around that. That's Newton's law. And then the rest is friction. And those frictional, that friction tends to be on the order of 15% for most materials. And even with coal, which is quite lighter, it might be in the 20% range. So it's a very, very efficient system. A conventional conveyor as an elevating means is also a very efficient system. If you put a conventional conveyor at about 15 degrees and you elevate it 100 meters or 50 meters or whatever, it also will be 15% losses, 85% efficient. So it's just a very, very efficient system. I can't think of another system that is that efficient. A truck surely is not.
No.
And yeah.
And what about the capital cost? So just maybe would it be competitive with a standard conveying solution?
Of course, yeah. When you actually do a total system cost, and this is important, when you do a total system cost, it's going to be the most efficient system. A conventional conveyor, as I said, it's an open trough conveyor. If you make it a ramp, spiral conveyor, one flight to another, whatever, it'll be on stringers, tables. You walk alongside of it, and it'll be very cheap. A high angle conveyor is never that. It's always, unless, there's things you can do to carve it into a wall, but that's not usually the case. Usually you're basically spanning from benches to benches. So it's typically an elevated conveyor system. So you're basically comparing something that sits on the ground, very cheap structure, to a spanning structure with access. I say this because too often people want us to tell them how much it costs per foot of length, because they want to compare it against a conventional conveyor per foot of length. Of course, the conventional conveyor sits on the ground and per foot of length only elevates 10 feet, while ours elevates 50 feet. So it's not an apples to apples comparison. And so try not to get into that. But when you put it in an application and you count all of the costs associated with it, for instance, on the high angle conveyor, you'll be spanning from bench to bench. Those are normal mine benches. Nobody's carving those for the high angle conveyor. They're carving them to establish a stable slope and just basically excavate what needs to be excavated from the pit in order to get the ore, nothing additional. In the case of a conventional conveyor, if you do a spiral ramp, the stair step of the conventional conveyor represents that stair step, which goes around the entire spiral of the ramp. That excavation goes all the way up the stable slope, all the way up to the surface. That's material that does not have to be moved if you attack the mine bench and go straight up it. So that's and that's not the worst. As I said before, there's many examples, especially in the 70s in the United States, where they would cut a slot into a very deep pit, and the amount of excavation associated with that is just enormous. All of that has to be considered too. And then the other method that they would do is they would basically come in with the TBM, and they would make a tunnel from wherever the base of the start of the excavation to wherever the surface was, just basically avoiding the natural slope, just coming out some remote place past the pit perimeter. That if you add all those equipment, if you add all of those expenses associated with that, the high angle conveyor wins hands down.
Yeah, no, I mean that makes a lot of sense. I guess maybe just to wrap up, but is there something, looking forward, what do you see the future of this technology, both I guess in terms of the technology itself, and also the take up of it in the industry? Do you have any thoughts on that?
Well, we've had great success in areas. Well, we envision a lot of these areas, but we've had great success in areas that are somewhat of a surprise to us, and that will continue. Tunneling, for instance, we've had very good success in tunneling. One of the things that I did not mention with regard to the comparison of bucket elevators, pocket belts, and high angle conveyors is basically smooth surface rubber belts. They can be scraped clean. You can discharge them fully. If you're handling mucky material, muddy material, whatever, like in tunneling, and you do that on a pocket belt, you have a hard time getting that material off the belt, not returning back to the bottom. And they use belt beaters on the back of those pockets and that sort of thing. In fact, we had a project where our systems were on the Paris metro expansion. I don't know if you're familiar with that project. It was a very, very big project. They actually specified sandwich belts for the elevating purpose to the exclusion of the pocket belt. And the pocket belt has actually been dominant in the elevating from tunneling projects. In this case, they were not even allowed because of that. Same thing with the pocket belts. You will take a lot of that material back. There's no way of ensuring that you're going to discharge it if it's a very sticky material. The sandwich belt conveyor has the ability to scrape it just like any conventional conveyor. So that's a great advantage that it has over those systems. And I apologize because I sidestepped, and your question wasn't that.
No, just in terms of the future, I guess, of these systems. And you were saying that there'll be, new applications that you didn't foresee. But just, what are some of the, development that you guys are doing, and what do you hope to see, I guess, in the future for the technology?
Okay, indeed, the successes will continue. The successes of the past will continue. They are continuing. The mining applications will happen. In fact, they have happened. They just have not happened in the pit with the success rate that we've envisioned. They will happen. They're in Australia. We've had great interaction with some of the iron ore companies there. In fact, we've done paid work with them, which will lead to installations in South America at the copper mines, without question. In fact, they're all doing studies now. How can we get this material up the pit, and can we do it at 15,000 tons an hour? These are tonnages that are previously unheard of, and we can demonstrate and haven't demonstrated that our system is already there. It's always been there. The ability to do this. So that's I think that's in the future. But that actually represents fulfillment. It does, all of that should have happened a long time ago. It's just slow coming, but we've had successes that way. Some really, really exciting things that are happening right now is at the University of Arizona. They're doing lunar mining investigations, both lunar and Mars mining project concepts, and they're bringing us along. It's again, who would have thought? But it turns out, in the case of the moon at 1/6 gravity, trying to keep material on a trough belt or any other system is difficult, and the sandwich actually presents a great opportunity to trap the material, basically, hug it, hold it, and convey it, so that the big challenges, will be actually to transfer the material into the feeding system. But the idea of sandwiching is actually very promising. They're very excited about it. They've sort of brought us in along that, and so both on lunar mining and on Mars mining projects, it's all the rage is being considered. So yeah, go figure. That's
not that.
That's very.
It makes sense, but I guess it's not something you would have expected when you started out 40 years ago that was the potential application.
Strangely enough, I'll go back a little bit, sort of along the same lines. The unexpected. About I'm trying to think how many years. Quite a few years ago, we had an approach from a customer that wanted to use high angle conveying and dredging. Again, I would never have thought, because the underwater environment is quite different than the surface atmospheric environment. But they saw this as the way to do it. These are dredging experts that basically use either a screw type or bucket wheel to paddle material into a suction pipe, and then they suction it out. And apparently that creates a lot of turbulence and the like. And they saw our system as being a good possibility. And at that time, we basically built a small model of it. The first thing we did, we have a demonstrator model that we use at trade shows. First thing we did was we went out and bought a fish tank and just dipped the darn thing in there and started conveying, seeing how that behaved. And then ultimately we worked with them to develop basically a dredge based on the sandwich belt principle. To this date, it has not happened, but it did work. The system works very well. And one of the things that I always thought when they brought the whole thing up, there'll be mud everywhere. Now it actually operated very cleanly. In fact, it basically did not kick up the mud. That was what they saw in it. So
yeah,
that was surprising.
Yeah, no, look, I think it's a fascinating area, and probably could go on talking and hearing stories for a long time, but we might wrap it up there. I mean, I learned a lot from the conversation. See, you have so much knowledge in the area, so I really appreciate your time, and I'm sure that if there's people out there listening that are interested to know more about the sandwich conveyor and its applications, I'm sure there would be you'd be happy to, or the team there would be happy to have a discussion with them about it. And I think for me, I'm keen to understand more about the economic comparisons to other to trucking, to conventional conveying and things like that. So you never know, maybe we could talk about that again on a future podcast. But thank you very much for your time. And thank you everybody for joining us on Fresh Thinking by Snowden Optiro. If you enjoyed the podcast, please subscribe, and you can find this anywhere where you find normal podcast platforms. Look forward to speaking to you next time.